geologic events. This is super important. So the distribution of rocks and their contact relationships describe geologic events. And these events are going to be in one of the following categories. Deposition. So if we see a sandstone, that implies that there's a geologic event, that was the deposition of the sandstone. Igneous rocks, if we see them, that implies that there was an intrusion or an eruption. So the event is that igneous rocks intruded or they erupted. Metamorphism is a third type. And all three of these are events that form rocks. So if we see a quartzite, we have two events. There was a deposition of a sandstone, and then a metamorphism to turn the sandstone into a quartzite. So it's important that you have the background we just went over in order to really make a good evaluation of the geologic events. In other words, the geologic history. So another one, erosion. Faulting. Tilting. And folding. So there's seven main geologic events. 3 of them that are responsible for forming rocks. 4 of them that are things that can happen to the rocks. Sort of structural things. We've talked about faulting in detail. We'll talk more about folding. And the last part of this are the geologic rules. So these are sort of like, of course rules can be broken, but there's eight sort of general things to just have in the back of your mind related to rocks and geologic events. So non-metamorphic layered sequences have a uniform direction of younging. So this goes back to when we were talking about the way up. So that uniform direction of younging was perpendicular to bedding. So in other words, a way up. So this is just saying sedimentary rocks generally have layers, and those layers are sequentially laid down so that if you look at the layers, you can go up and down in time, basically. Number 2, preserved rock strata are usually deposited in horizontal sheets parallel to Earth's surface. So what that means is if we find sedimentary rocks at some angle, dipping at some angle, 20 degrees, 40 degrees, that means they've been tilted, okay? Because when we look around at rivers, lakes, ocean basins, the rocks that are being deposited are essentially horizontal, no more than a couple degrees. Strata, so these rock layers, tend to be laterally continuous. Until thinned to 0 thickness. Or abut an edge of a depositional basin. So basically this one means geologic layers don't tend to, sedimentary layers, at a large scale don't tend to just end. They don't just end abruptly. Like they tend to get thinner. If you find some quartzite layer, it tends to go on for a long distance and gradually get thinner. Usually doesn't just end abruptly. Intrusions, number 4, intrusions are younger than the rocks they intrude. So this one might seem kind of obvious. We call that rocks they intrude the country rock. So that's like the stuff that was there already. Intrusive contacts form at any angle relative to Earth's surface. So unlike the sedimentary rocks that were, we know that they were originally horizontal. The boundary between a granite and some metamorphic rocks could have originally been at any angle. So we can't infer tilting necessarily. Number 5, metamorphic foliations. So this is or I'll introduce another word, cleavage. So we're going to talk about these in more detail later, but foliations and cleavage are planar layering that's not sedimentary, that develops when rocks are strained at high temperatures. So metamorphic foliations or cleavage die out over many kilometers, and more importantly, they form at any angle. So just like the intrusive contacts, the foliation, the layering of a metamorphic rock will tend to go on for a long distance. And the Manhattan schist is a great example of that. It has a layering and a tilting, all from one end to the other of more or less of Manhattan, and we don't know if that layering that we see, if that used to be, if it's been tilted. It could have formed at the orientation it is. And we will give some examples of these rules soon. Number 6, detrital sedimentary rocks contain information about previous events. And conglomerates are especially useful for this because there's nice big chunks of some old rock. So if you find a conglomerate, so conglomerate's a coarse sedimentary rock. So if you find an amphibolite, a metamorphic basalt in a chunk of it in a conglomerate, you've got quite a few geologic events right there, because you have the deposition of the conglomerate, but before that there must have been a basalt. So there was an eruption of a basalt, and then it was metamorphosed into a amphibolite, and then how did that get to the surface? So there must have been an erosion event, and then there was a deposition event where that stuff that was eroded was deposited to form the conglomerate we're looking at. So detrital sedimentary rocks are very useful. Metamorphic rocks form either so we've already said this, form either from igneous or sedimentary rocks. And finally, geometric truncations of one planar surface by another indicate the truncated surface is older. So this is kind of like in the cross-bedding example where we have these layers, and then there's some other layers on top. So obviously this stuff that got cut off is older. Partly we know that from our rule about strata number 3. Strata tend to be laterally continuous. So these layers that we just see suddenly cut off, they wouldn't have formed that way. So this lecture is actually pretty important one. So you want to have this material down. This is pretty much review. It should be from 106. In any case, it's but I realize that a lot of times the students don't really remember this, or it was presented in different ways, and so this is key, because we're going to be looking a lot at geologic maps and trying to interpret them, and we need this foundation in order to do that. So go over this and make sure you understand it. Make sure you know all these words that we've used. And the next video will give you some examples of interpreting geologic events.